that this week's 7 AI papers actually mattered. We read every one, rank them, and there's a clear winner. Counting down to number 1. Number 7. The best AI agent scored 52% on this planning test, then crashed to 11 the moment a tool broke. This is about tool use agents, AIs that pick from a pile of tools to finish a multi-step task. Most benchmarks hand the agent a tidy little toolbox. Real systems have thousands of tools, half of them irrelevant and some that just fail mid-task. So the authors built PlanBench-XL, 300 tasks across over 1,600 tools, with an optional setting that makes tools go missing, fail, or distract. 10 top models all struggled, and they fell apart hardest when a failure gave no clear error to recover from. For anyone shipping agents on real tool stacks, this is the gap to watch. Verdict, read. And number 6. Drop your character into a video and let it keep its face while everything else changes to match the prompt. This is subject-driven text-to-video. You give one reference image and the model generates new video of that same subject. The catch today, most methods clamp down on the reference so hard to stay faithful that you lose the ability to restyle it. Want your character in a new art style, a new setting, a new combination? The faithful models fight you. DomainShuttle fixes that by treating the two jobs separately. Keep the subject, but let everything subject irrelevant flex with the prompt. It puts the reference and the video in their own coordinate spaces and learns the subject's core identity apart from the noise around it. The result is both higher fidelity and far more editing freedom across in-domain and cross-domain scenes. Like if you generate video, this is a stronger base for personalization, and the code is open today. Verdict, read. Number 5. You can now walk through an AI-generated world, look away, turn back, and it's still there exactly as you left it. This is a world model, an AI that doesn't just make a video, it simulates a place you can move around inside. The hard part is memory. Most generators drift, turn the camera away, and the scene quietly mutates, colors shift, the room you just saw is gone when you come back. DreamX-World 1.0 fixes the drift. It generates long, controllable scenes from text to an image, photorealistic, game style, or stylized, with real camera navigation and a memory system that retrieves earlier views so revisited places stay consistent. You can even drop in promptable events mid-scene. For anyone building game engines, simulators, or interactive video, persistence is the unlock. This is a serious step toward it. Verdict. Number 4. The 7B coding model just jumped from 43 to 64 on StebuEvenBench by running the same layers twice instead of once. This is about looped transformers, models that reapply their own blocks to think a bit harder before answering. The catch nobody pinned down: how many loops is actually worth it? More loops cost latency and memory, and everyone just guessed. So they trained loopcoder-v2 from scratch at every loop count and measured. 2 loops is the sweet spot. SweBench verified climbs from 43 to 64, multi-STWIPy from 14 to 31. 3 or more loops actually regress because the extra refinement shrinks while the cost stays fixed. If you build coding models, this is a clean, free-ish capability boost and a hard rule for where to stop. Verdict, read. Number 3. If you're picking a memory system for your AI agent, this study says there is no best one, and most benchmarks are testing the wrong thing. This is about agent memory, how an AI agent stores, retrieves, and updates what it has learned across a long task. The problem: today we grade memory by whether the agent finishes the task. That treats the whole memory system as a black box and hides what actually costs you: storage, retrieval accuracy, and whether it stays stable as knowledge keeps changing. So the team broke memory into 4 parts: how it's stored, pulled out, routed, and maintained, then ran 12 memory systems across 11 datasets. The verdict: no architecture wins everywhere. What works depends on which part of your workload is the bottleneck. And patching memory locally beats rebuilding it from scratch every time. If you build agents, this is the map for choosing memory by your actual workload. Code is open today. Verdict, read. Number 2. A model 50 times smaller just matched the big ones at erasing things from photos. This is about image inpainting, telling a model to fill in a region of a photo so the patch looks like it was always there. The catch is that the models good at this are huge, 10 billion parameters, so they're slow and expensive to run. Moebius does it with 200 million. It pairs local global interaction blocks which keep tiny edits consistent with the whole scene, with adaptive distillation where the small model learns directly from a big one. The result matches 10 billion level quality at a fraction of the parameters and inference time. If you ship anything with object removal or fill, this is the kind of model you can actually afford to run. Verdict, read. Number 1. Mate, to be asked, it just watched and spoke up the second something mattered. This is about interaction models, vision language AIs that see a live video stream and act on it in real time. Today's models are turn-based, they only answer when we prompt them. Even live video apps just poll for a question. So the fire on the security feed, the expression that flickers by, the product flashing through a stream, all of it passes unremarked. JoyAI-VL-Interaction is an open 8B model that flips that. Every second, it decides on its own to stay silent, respond, or hand a hard problem to a bigger background model. And from that one recipe, behaviors they never trained for emerged, guiding a shopper through changing screens, improvising a lecture from a slide deck. The model and full deployable system are open today. If you build anything that has to react to the world, this is a new starting point. Verdict read. That's the cut for this week. New papers, same honest verdicts every Sunday. Subscribe for the weekly paper cut.